Solutions to inequalities. So last week we started talking about inequalities. And remember, inequalities are comparing two numbers. And when we compare those two numbers, we use four different symbols. Remember, we use greater than, less than, greater than or equal to, and less than or equal to compare two numbers. And last week, we ended the week by starting to talk about how we can use inequalities, kind of like linear equations, to solve for missing values. But we use inequalities because we're not saying that our solution is, or we're not saying that our missing variable is equal to a number. We are saying it's either greater than, less than, greater than or equal to, or less than or equal to a number. So that is why we use inequalities. So instead of saying something is, he wants to make $1,500. When we use inequalities, we say he wants to make at least $1,500. So he would be happy making $1,500 or more, but he would not be happy if he made less than $1,500. So that is why we use inequalities. And today we're going to keep looking at story problems to understand how we can write inequalities from these story problems. And then we're also going to look at how we can graph these story problems and inequalities. And graphing inequalities is a little bit different. I think we talked about graphing inequalities at the very beginning of the year, but we're just going to do a quick review before we actually do it. So I'd like to take a look at exercise number 1, and this is going to take us into the mindset, of graphing inequalities. But we're not going to do it for this exercise. So exercise number 1 says 2 identical cars need to fit into a small garage. The opening is 23 feet 6 inches wide, and there must be at least 3 feet 6 inches of clearance between the cars and between the edges of the garage. How wide can the cars be? All right, so we're looking for the width of the cars, but we're going to first write down the information that we know. So I'm going to draw out a garage here. And they told us that our garage, so this opening right here, the entire opening, is 23 feet 6 inches wide. And they told us that we need to fit 2 cars into this garage, but there needs to be the same amount of space between each car and the edge of the garage, and then between the 2 cars. So between the car and the edge of the garage, we need 3 feet 6 inches of clearance. Between each car, we need 3 feet 6 inches of clearance. And between this car and the edge of the garage, we need 3 feet and 6 inches of clearance. So what we can do with this information, yes, ma'am. It would be helpful if you took notes on it, but you don't have to if you don't want to. Whatever will help you in terms of your homework. So I would say yes, but it's completely up to you and the resources that you have available to you. Thank you, Diana. Okay, so in terms of this problem, what we're going to do is first, for me, it's easier if I convert 3 feet 6 inches into just feet, because eventually I'm going to have to subtract the amount of space that I'm using up in this garage from the total amount of space in the garage, so that I can start to figure out how wide these cars will be. So I'm first going to turn, or actually I'm first going to turn 3 feet 6 inches into just feet. So this is what I know. I know that there are 12 inches in 1 foot. So 12 inches equals 1 foot. And I know that 6 inches equals half of a foot. So right here, I have 3.5 feet because I have 3 feet 6 inches. And if 6 inches is really half of a foot, I can rewrite this as 3.5 feet. And that is representing the same thing. And remember that when we're talking about feet and inches, we use these little symbols. We use just one line above the number to represent feet. And we use 2 lines above the number to represent inches. So notice I had 3 feet 6 inches. And because I know that 6 inches is half a foot, I could rewrite this as 3.5 feet. And that helps me in this problem. So now I know that there are 3.5 feet of space between each car and the wall of the garage and between each car. And then I also know that my garage is 23 and a half feet long. That's how much space there is width, in terms of width. That's how wide the opening of my garage is. All right, so now I understand that there are 3 spots in my garage where I need 3.5 feet of space. So I'm going to multiply 3 by 3.5 feet so that I know the total amount of space that I'm using up as I'm creating this space between my cars and the walls. So when I multiply 3 by 3.5 feet, I get 10.5 feet as the amount of space that we need in total. So this is amount of space needed, and that's important because this is going to help us determine how wide those cars are. So this is amount of space needed. And now we're going to use that information and subtract it from the information that we already know. So we know that there are 23.5 feet of space in the entire garage. The whole garage is 23.5 feet wide. But I need from that garage 10.5 feet so that there's enough room between my car and the wall, between my other car in the car, and then between the other car and the wall. So from this 23.5 feet, I'm going to subtract 10.5 feet. And when I do that, I get 13 feet. But remember, my question is asking me how wide can each car be? So this is telling me that my cars in total, when I put them together, can be 13 feet wide. But I want to know how wide each car can be. So I'm going to take 13 feet and I'm going to divide it by 2. And when I divide 13 feet by 2, because it's 2 cars, I get 6.5 feet. So that means that each car can be 6.5 feet wide. That's how wide each car can be. Okay? So that means that if I'm going to have 3.5 feet of space between each car and the wall and between each car can only be 6.5 feet wide. But each car can only be up to 6.5 feet wide. It could be less than 6.5 feet wide, but it can't be greater than 6.5 feet, or it won't fit in the garage. They won't fit in the garage. 2 cars greater than 6.5 feet wide would not fit into our garage with this amount of space that we want. So this is going to introduce us to inequalities, and this is why. So I'm going to start writing up here. So they told us that we have 2 cars and we're trying to figure out how wide they are. So I have 2 widths that I'm trying to determine. And I already determined that the amount of space that's needed in my garage is 10.5 feet. So I'm going to say 2 cars, the width of 2 cars plus 10.5 feet is the amount of space should be less than or equal to the amount of space total in my garage, which is 23.5 feet. So this now is us using inequalities to solve this problem in a different way, okay? So when I'm looking at this inequality, what I'm trying to do is solve for W. I want to know how wide each car can be. So in order to do that, I see that 10.5 is being added to the left side of my inequality. So I'm going to do the opposite of addition, and I'm going to subtract 10.5 from both sides of my inequality. So I'm going to subtract 10.5, and I end up with, again, 13 feet of space. So I now have an inequality that says 2W is less than or equal to 13 feet. So now since that 2 is being multiplied by the W, I am going to divide both sides of my inequality by 2. And now what this says, I'm going to erase this right here. This says W, or the width of each car, is less than or equal to 6.5 feet, because 13 divided by 2 is 6.5. So the width of each of my cars has to be less than or equal to 6.5 feet in order for them to fit into my garage. The width cannot be greater than 6.5 feet. Now, I want to remind you guys of something before we move on. So we looked at a bunch of tables where we looked at the symbols of inequality, and we looked at what would happen if we multiplied our inequality by a positive number, what would happen if we multiplied it or divided it by a negative number, and then what would happen if we added or subtracted a positive number or a negative number to our inequality. And we saw when the signs would change. And we understood that the signs change when we multiply or divide by a negative number. So you guys are going to see in just a few minutes, actually in this next problem, when we divide or multiply by a negative number in terms of our inequality, we need to change the sign. So I just want to remind you of that. When we multiply or divide by a negative number, the sign changes. Don't forget that. The sign changes. And this is really important because in the next problem you're going to see that we need to change the sign in order to make the statement still true. So I'm going to move ahead so that we can see this next example so that we can go through it together and understand why this is true. You're not done copying it down? Okay, I'll wait just a minute. The arrow thingy? You're saying multiply or divide by negative numbers. The sign is going to change. Is that what you're copying down? Okay, thank you. All right, let's look at our example here. So our example, this is going to be just like we just did, but the words might change just a little bit. And this time we're going to graph this inequality. So we're going to look at how we graph inequalities now. All right, so a local car dealership is trying to sell all of the cars that are on the lot. Currently, there are 525 cars on the lot. So before I do anything else, I'm going to write down that 525 because it's going to be somewhere in my inequality. I'm just not sure where yet. Okay, and the general manager estimates that they will consistently sell 50 cars per week. So that means that we're going to take away 50 cars each week. So I'm going to subtract 50W from my total, from the total amount of cars that are on my lot. And then it says, estimate how many weeks it will take for the number of cars on the lot to be less than 75. So now we know that our inequality symbol is just less than because we want less than 75 cars on our lot. We don't want greater than, we don't want equal to 75, and we don't want greater than or equal to 75. We just want less than 75 cars to be on the lot. So we're just going to use that less than symbol here. So it says write an inequality that can be used to find the number of full weeks W it will take for the number of cars to be less than 75. Since W is the number of full or complete weeks, W equals 1 means at the end of week 1. All right, so that means that if we solve for W, we're going to know how many cars, how many full weeks we need to sell 50 cars per week for. So we're saying that W is equal to 1. We're selling 50 cars per 1 week. Okay, so we just wrote out our inequality with the information that we have 525 cars on the lot, and we're taking 50 cars away from our 525 each week, and we want to end up with less than 75 cars on the lot. So we're trying to figure out how many weeks we need to sell 50 cars for in order to get less than 75 cars on our lot. So I'm going to rewrite my inequality so that I can solve it. So it says 525 minus 50W is less than 75. And now I'm going to solve this inequality. Now notice when I solve this inequality, so I have a positive 525 on the left side of my inequality, and I have a positive 75 on the right side. So those are like terms, and I need to combine them. So in order to combine my like terms to get W by itself, I need to subtract 525 from both sides of my equation. But what you can see is when I subtract 525 from 75, I'm going to get a really big negative number. So my negative number is negative 450. So now I'm going to write out what my inequality is saying. So it's saying negative 50W is less than negative 450. Now, this is where that information about changing the sign comes in. And this is why. So I have negative 50 in front of my W, which means I need to get rid of that negative 50. And in order to do that, I'm going to divide both sides of my inequality by negative 50. But when I do that, I need to change my inequality symbol because I just divided by a negative number. That's one of the rules of solving for inequalities. So I'm going to change my inequality symbol to now say W is greater than, and remember when we divide a negative by a negative, we get a positive. And when we divide 450 by 50, we get 9. So that means that we are going to have less than 75 cars on our lot when we sell 50 cars for more than 9 weeks. That's what we're saying, okay? But before we interpret that, that inequality in our next slide, we need to graph this inequality. So I want to remind you guys of two things. I want to remind you that when we're graphing inequalities, an open circle is greater than or less than, whereas a closed circle, so remember, a closed circle is greater than or equal to or less than or equal to. So when we're graphing this inequality, remember, we're just going to use a very simple number line because that's all we're just comparing numbers. So we're going to use a number line to compare our numbers. And when we're graphing these inequalities, we don't need a complete number line. We just need to be able to show what our inequality is saying. So our inequality is saying we have to sell 50 cars per week for more than 9 weeks. So I could start my number line really anywhere I wanted. I'm going to start it at 5 just so I can show that I'm comparing lots of different numbers. So here's 7, 8, 9. And since it's greater than 9, I'm going to make sure that I have numbers greater than 9 on my number line. And now what I'm going to do, since I have an inequality that's just greater than, I'm going to put an open circle at, whoops, I did that incorrectly, I'm sorry, at, now I messed the whole thing up. Sorry about that, guys. Here's 10. Okay, so I'm going to put an open circle at 9. And from my open circle, I'm going to draw an arrow to show that that circle is, that I'm showing greater than or more than 9. So my arrow is pointing away from 9 to the right on my number line to show greater than 9. And I use that open circle to show that I'm just saying greater than. I'm not saying greater than or equal to. So that's how we're going to write our number lines today. We're going to use an open circle when we're talking about greater than or less than. And we're going to use a closed circle to say greater than or equal to or less than or equal to. And that open circle means that it's not equal to. This means not equal to. And that's what we're showing. Sometimes we don't want it to say equal to. And so we use that open circle. So in our next slide, we're going to interpret the solution in the context of the problem. And that's also important for you guys to understand. And here's why. So I'm going to flip to my next problem. Remember, if at any point you need to go back, I will post this at the end so you guys will be able to see that. All right, so it says, interpret the solution in the context of the problem. What's your question? Sure, Danny. Okay, thank you for asking. So remember that at the end of our problem, we had an inequality that said W was greater than 9. And remember, W was our number of weeks. So what we're saying, or what the question asked us, was how many weeks we needed to sell 50 cars per week in order to have less than 75 cars on our lot. So now what we come up with is that the dealership can sell 50 cars per week for more than 9 weeks in order for them to have less than 75 cars remaining on their lot. We can't sell cars for less than 9 weeks and have less than 75 cars. It has to be greater than 9 weeks, and it can't be equal to 9 weeks because we won't sell enough cars. So I'm going to show you guys that in just a minute. So in interpreting this inequality, we say the dealership can sell 50 cars per week for more than 9 weeks to have less than 75 cars on the lot. And less than 75 cars on the lot. And I want to show you guys why we can't say that we can sell equal to 9 cars. We have to say greater than 9 cars. And this is why. So we're going to verify our solution. And you guys are not going to have to do this in your homework, but it's still important for you to understand how to do it. So in order to verify our solution, we're going to use W equals 9 because we want to see what happens when we say equal to 9 weeks. And then we also want to see what happens when we say equal to 10 weeks, so greater than 9 weeks. And so we're going to rewrite our inequality. So we have 525 minus 50W is less than 75. And we're going to plug 9 in for W. So now I have 525 minus 50 times 9 is less than 75. So we're going to see if this inequality is still true, this statement is still true, when we carry out these operations. So firstly, I'm going to figure out what is 50 times 9. And 50 times 9 is 450. So now I have 525 minus 450 is less than 75. So I want to make this a true statement. But when I subtract 450 from 525, I get 75. So now my inequality is saying 75 is less than 75, which is not a true statement. 75 is equal to 75. So this is false. So we can't say that we can sell 50 cars per week for 9 weeks and have less than 75 cars. We will have equal, to 75 cars. So we need to sell cars for longer than 9 weeks. So let's see what happens when we sell cars for 10 weeks. So now we have 525 minus 50 times 10. And what we're hoping is that this is less than 75. So when we carry this out, we get 525 minus 500 is less than 75. And so we end up with 25 is less than 75. And that is a true statement. So what we're saying is that if we sell cars for 10 weeks, we will have 25 cars on our lot, which is less than our 75 cars that we wanted to have, less than 75 cars. So we have to say that we need to sell cars for more than 9 weeks in order to achieve that goal of having less than 75 cars on our lot. So that's why we would use an inequality in a situation like this one. So we're going to keep looking at these problems in order to better understand not only how to write inequalities from story problems, but also how to graph inequalities. So we're going to move on to another problem. And our next problem says, the cost of renting a car is $25 per day. So I'm going to write that down, $25 per day, because it's going to be somewhere in my inequality, plus a one-time fee of $75.50 for insurance. How many days can the car be rented if the total cost is no more than $525? So remember, if we see that no more than, we are meaning either less than or equal to or greater than or equal to. And since it says no more than, it can't be greater than 525. So it can be less than or equal to 525. So it asks us to write an inequality to model this situation. So there is our inequality modeling our situation. And now it's asking us to solve that inequality and graph it. So I like to rewrite my inequality so that I can solve it easier. So I've got 25D, and D is representing the number of days that I'm renting this car, plus 7550 is less than or equal to 525. So I'm going to combine like terms. So firstly, it's going to be easier for me if I add these zeros because this is a dollar. So right now, 75.50 is being added to the left side of my equation. So I'm going to do the opposite of addition, and I'm going to subtract 75.50 from both sides of this equation. And when I do that, I end up with $449.50. So now my inequality says 25D is less than or equal to 449.50. And I'm just going to write 0.5. Now, anytime I see a number being multiplied by a letter or a number next to a letter, I know that it's being multiplied. So here, in order to get D all by itself, I need to do the opposite of multiplication. So I'm going to divide both sides by 25. And I end up with D. We're going to keep our inequality symbol the same because we did not divide by a negative number. So D is less than or equal to 1798. Now, this is asking us how many days a car can be rented if the total cost is no more than $525. So please keep that in mind when we switch to the next problem to interpret the solution in the context of the problem. But before we move on to that problem, we need to write out or draw a graph to show what we're doing here. So remember, we can start our graph anywhere. So I'm going to start it at 15, 16, 17, 18, and I'm going to go up to 20 on my graph. There's no real good reason for that. It's just what I decided to do. And so right now, since we have less than or equal to, I know that I'm going to use a closed circle. And $17.98 or 17.98 is just less than 18. So I'm going to put a closed circle at just less than 18. And since I'm saying less than or equal to, I'm going to draw my arrow toward the left side of my graph to show that it's less than. So we've got that closed circle that shows equal to, and then we have our arrow that's showing less than or equal to. All right, so there's our graph of our inequality. And now we have to interpret the solution in the context of our problem. So again, they asked us how many days can the car be rented if the total cost is no more than $525. We cannot say that the car can be rented for 17.98 days. That doesn't make any sense. What we can say is that the car can be rented for at least 17 days, but no more than 17 days, because if we say the car can be rented for 18 days, it will take us over that $525. So we're going to say the car can be rented for 17 days or less. And that is how we interpret the solution to our inequality. Remember, if he rents it for more than 17 days, it will cost him more than $525. And he wants to rent either, or he wants to spend either $525 or less than $525. So he has to rent the car for 17 days or less. Okay? So we have just 3 more problems to go through so that you guys are exposed to as many of these as possible before I set you free and let you go and do the exit ticket and problem set. So we're going to go ahead and move on to looking at another exercise, which is problem number 3. So for each of these additional problems, so 3 through 5, it says for each problem, write, solve, and graph the inequality and interpret the solution within the context of the problem. So for number 3, it says Mrs. Smith decides to buy 3 sweaters and a pair of jeans. She has $120 in her wallet. If the price of the jeans is $35, so we know the price of the jeans is $35, we also know that she's buying 3 sweaters, so 3S. We don't know the cost of those sweaters yet. What is the highest price, the highest possible price of a sweater if each sweater is the same price? All right, she has $120 in her wallet. So she can spend less than $120, or she can spend equal to $120, but she cannot spend more than $120 because she doesn't have more. So what we're trying to figure out is what the cost of each sweater is if each sweater is the same price. So we're going to combine like terms. And in order to do that, 35 is being added to the left side of my equation. So since it's being added, I'm going